welcome to another Generative Components tutorial. Today we'll look at automatically generating spot levels from 3D meshes. So let's get started. For this exercise, I've referenced in the DEM mesh provided with the Metro Station example project, delivered with the Open Buildings dataset. You can see here it is made up of individual triangles or polygons. For this example, let's focus on a small section of this mesh. Switching over to the computational design workflow, I typically click on Point and click Yes and OK to generate a base CS. Then I can place 2 points, one at the top left and one at the bottom right of the area I'd like to select. Dragging in a range node, I'll first change the Z values of 0.1 to minus 50,000 and the Z value of 0.2 to 50,000. This will cover the range of Z values in the mesh. I can then link up 0.1 to low point and 0.2 to the high point on the range box. Next, I'll drag in a polygon node and change its method to from elements in range and link this up to the range node. Selecting the polygons node, you can now see I have 194 polygons. From here, I'd like to create points on each of the vertices of each of the polygons. To do this, I could easily drag in a point node and link up the polygon vertices, but this would produce a lot of duplicate points and not give us much control over the points themselves. Instead, I'm going to drag in a point node and change its method to by function, and then click on the box to open the editor. Starting the function with the word function, we can open brackets to define the inputs we need. For this, I'll start with polygon and call it input polygons, and then I'll set up an int and call it reduce detail. Then I can close the brackets and place open and close curly brackets to contain the function. My thoughts with this function was to loop through each of the polygons I created with the range, find their vertices, and generate points. But during this process, I'd like to check to see if I have a point at that exact location, and if I do, I'd like to skip it. With the reduced detail integer, I thought I might need a way to reduce the number of points. You might only want every second point or even 10th point. So to start, I define what I'd like as the output, and in this case a point, and call it myPointList, and equal that to an empty container with the open and close curly brackets. The next item I'd like to set up is a list of doubles that will be my XYZ values, so I can check against this to see if I already have this in my point list. This I am going to store as doubles rather than points, as I can easily use the contains expression to query the list. So to start the line is double, and then my XYZ list equals to an empty container and end with a semicolon. Now we need a loop, so I type for and then tap tab a couple of times to autofill the line. I'll then copy the input polygons and paste it in before the count and change it to .count with a capital C. Now inside this loop, I can create the points, starting with point called myPolyPoints equals new point, open and close brackets, dot by parameter along curve, and then open brackets. And now we want to use input polygons, square brackets, I dot control polygon dot line segments, which will extract all 3 of the line segments of the current polygon we're looking at. Then for the parameter, we'll use 0 to indicate the start of the line. Then we just need to close brackets and place a semicolon. As this looks at all 3 line segments of each polygon, we are going to get 3 points for each time we loop through a polygon. So to start to interrogate each of the points we just created, let's start a second loop, again by typing for and tapping tab twice. I will then change the I to J. And you can see by just changing the first I to J, all the others have changed as well. Now I can copy my polypoints and paste it in before count and change it to .count with a capital C. Now in this loop, I can look at each point individually. I will start with an if statement. So I type if and then open brackets, and then my XYZ list dot contains, and then open brackets, my polypoints square brackets J dot XYZ close brackets equals false, and then close brackets again. What this will do is it'll look at the current point, which is my polypoint in square brackets J, find its XYZ values, and then look inside the my XYZ list and see if it contains the exact values as a set. If it doesn't find a match, the result will be false, and it will keep processing this if statement. So the first step I do in the if statement is put the XYZ values into the my XYZ list by using my XYZ list dot add open brackets my polypoints square brackets J dot XYZ and then close brackets and a semicolon. Next, I can create the point by starting with the word point and calling it my PT equals new point, open and close brackets, dot by coordinate list, and then open brackets. For the coordinate system, we're going to use base CS, and for the coordinates, we're going to use my polypoints, square brackets J dot XYZ, and then close brackets, and then a semicolon. Now I just need to add this point to our output list by saying myPointList.add and copy myPT and open brackets and paste myPT, then close brackets and place a semicolon. The last step would be to replace a return myPointList semicolon at the end of the function, but this would return all of the points. So before this line, let's set up an if statement, starting with the word if, open brackets, and let's use the reduced detail is greater than 1, close brackets. The reason we're checking to see if the reduced detail is greater than 1, if a value of 0 or 1 is in the reduced detail input, it will probably error in the next steps, or at least return the same results, so let's just make sure that it's above 1. So we open and close the curly brackets for the if statement, and inside I will set up a new integer list. For this, I type int and call it myFilter. I'm going to equal this to a series. So we type series, and we open brackets, and we're going to start from 0, and then comma, and then for the limit for this, it'll be myPointList.count, and for the steps, I'm going to use reduce detail and close brackets. This will create a new list of values starting from 0 and stepping up to the count of myPointList, stepping by the number in reduced detail, for example, say 5 or 10. Now to get the new list of points, we can simply say point and call it, say, myPointListFiltered equals members at, open brackets, myPointList, which is the list that we want to select the members from, and then myFilter, which is the list of indices for the members we need. Then we close brackets and end with a semicolon. Now we can just return myPointListFiltered. If reduced detail is less than 1, then we need to do something else. We can use an else statement and open and close curly brackets around the return myPointList, which is the unfiltered list. To make it a bit easier to read, I'll just indent this part. Let's click apply and close the window. Now for testing, let's place 10 in the reduced detail input and link up input polygons to polygon 1. And we have points on most of the indices of the polygons, probably about 1/10 of them. Let's change the reduced detail back to 1 and we should see a point on each of the vertices. If I select the point node, you can see now there are 109 points. And if we look back at the polygon 1, we had 194 polygons, so it is working at removing the duplicates. Let's change the reduced detail to 5 and move on to creating some text. First, let's drag in a text style node and change the width and height settings to 10, justification to left center, and let's set the X offset to 500. I'll also pick Arial as the font. Dragging in a text node, I'll link the text value to the point 3 and change it to point3.z. And then let's start this with a round. So we'll type in round and then open brackets before point 3, and then we'll add a comma after point3.z and then put in 2 as the number of decimal places and then close brackets. Then I can link the placement to point 3. Now looking at this, it is nowhere near the points, but I haven't linked up the text style yet. So let's click on the drop down and pin the text style and link it up to the text style node we created. You can now see they are right next to the associated points and much smaller. They are, however, in millimeters. So let's open up the text value and include a divided by 1000 after the point3.z. Now it looks much better, but we don't have a marker. So let's drag in a cell node and change some of its values. Let's change the X and Y scale to 5. The library I have for this marker is site.cell. So I've just included that inside inverted commas. Closing that dialog, the cell name for this is spot_level, which I place inside parentheses. And for the placement, we can link it up to point 3. So now if we change the reduced detail to 1, we get a spot level marker and text at every point. If I reduce the size of the text to 5 and the cell scale to 2.5, it is much more legible. Maybe as an average, changing the reduced detail to 2 for this example will give a good balance. If we rotate the view, you can see the points and the text are located at the correct RLs. Now it is just a matter of adjusting the range box to cover the area we'd like to address. One good way of doing this efficiently is to right-click on the range node and select Defer Update. You can now freely move the points around without the delay of updating the whole script while dragging the points. Once I moved the points to a wider area, I changed the reduced detail to 50 to speed things up, and then it was just a matter of right-clicking on the range node again and turning off Defer Update, and all the spot levels are automatically generated. Now we could easily update the reference file and adjust the range box as needed, and the spot levels will be automatically generated. Hopefully you'll find a way to incorporate this concept into your next project. Until next time, thanks for watching.